This is Mission Control Houston again, looking down inside of the International Space Station Flight Control Room here in Houston. One of the remarkable things about the station being how many centers and countries around the world have been involved. One of the other U.S. centers, the Marshall Space Flight Center in Huntsville, Alabama, taking a very integral role in all space station operations. Why don't we go out there now where Lori Meggs is standing by live. Lori, I understand you have some pretty amazing people out there who have been contributing to the past 15 years as well.
That's right. You know, we've talked a lot about the folks behind me here in the Payload Operations Integration Center. I mean, they make science happen every day. We talk about their contributions almost weekly, daily, but we wanted to introduce you to some folks who've actually played a role in the hardware. Marshall has done a lot of work in that, and joining me now is Brian Mitchell. And Brian, he was the Element Project Manager for Node 1, which was built right here at Marshall. Brian, thanks for joining us. Take us back to those early days. I guess it was more than 15 years ago, really, for you guys.
Yes, ma'am. Good morning. Let me first say I consider myself lucky and privileged to have worked on the node and all the pressurized modules. It's not every day that you get a chance to crawl in each module and see it from the time it was in the paint booth to the time it was launched at KSC. The node, lab, and airlock were all manufactured here in Huntsville, and the assembly and integration took place here. The early emphasis of Space Station was on qualifying the structural integrity of the pressurized module, providing a robust sealing capability, and finally the ability to attach the modules in space.
The node made it all possible, right, to start the assembly, really?
Yeah, well, the node paved the way for a lot of common hardware that was used by all the other modules, such as the hatches, the fluid and power connectors, seals, and the common berthing mechanism, also known as the CBM.
Now, how many ports were on Node 1? Are on Node 1, I guess I should say.
Node 1 had 6 ports. They had 2 pressurized mating adapters on the forward and aft end, and it also served as the hub that all the other U.S. modules was attached to.
Tell us more about those common berthing mechanisms.
Well, the CBMs are primarily consist of alignment guides, capture latches, powered bolts, and controllers that allow automatically attaching the modules together in space.
That's no easy task, I'm sure, right?
No, it was. We were quite nervous when we first started, but the CBM has performed great over the years. In the 15-year history, CBM has performed 41 berthing operations, 31 deberthing operations, and it continues to be used today by our payload delivery with Japanese HTV, as well as SpaceX and Orbital delivering cargo to space station.
Working just as you planned so many years ago, right?
Yeah, we were real nervous when we first started, but as time went on, we gained a lot of confidence, and it's performed beautifully over the years.
As we celebrate this 15th anniversary, what do you want others to know about the space station?
Well, one thing that amazes me about the space station is that people almost anywhere in the world can go outside, and when the weather's right and the time's right, you can see the space station flying overhead. And to me, that's amazing. And I just want them to know that the pressurized modules, as well as the hatches and the CBMs, were all manufactured and built here at Marshall, and all the testing and qualification was done here at Marshall.
Tell us something unique about, or maybe a story from way back then. I know that you kind of came up with something to help out on the project. It's made of a hockey puck. I don't know if we had that with us.
Yeah, I have it sitting over here in the chair, but we actually had, when the nodes were in the paint booth as the first element, we had a lot of feed-through connections that we had to provide nickel plating so that we could get an electrical bond. And we were having trouble providing a good smooth sealing surface for that. So I had the idea for a tool, and I went down to the hockey rink, and I got a hockey puck, and I made a tool that actually you could stick in the feed-throughs and sand the nickel plating, and when we got done, it turned out great. All of the nickel turned out to look kind of like record albums, and it worked very well.
took a lot of innovation like that back then. Thank you so much, Brian. Thanks for sharing with us. We also want to talk about the hardware for the payloads. We've played a big role in that and continue to this day. Mike Cole is the deputy manager for the ISS office here at Marshall. And Mike, you were also the project manager when they delivered the Microgravity Science Glovebox. Tell us about that.
I appreciate that. It was a joy working on some of the early payloads and facilities that were flown to the station. Here at Marshall, we were responsible for quite a few different facilities. We had, from the vehicle side, several of the key systems like the environmental control and life support systems, which included a water recovery system that had a urine processor assembly associated with it, and an oxygen generation assembly rack as well. And obviously those were very important to keeping crew tended on the station.
Critical, and then when we increased numbers of crew members too, I mean, it's
absolutely,
critical.
That's right. And then from the payload facilities, as you mentioned, the glove box, and that was actually a facility that was a bartered payload, so it was designed and developed by the European Space Agency. However, we at Marshall managed the program and have the integration team, so we help the payloads that fly in the facility. We do the integration process and help them get ready to do all of their science and research on the station. And it's a unique facility because besides distributing station resources, the power and data and the video and those things, it also provides a work volume that's 2 levels of containment, so that it does hazard control for being able to, from a safety perspective, and it has the glove port, so it's a very interactive with the crew. So it gets a lot of, I guess, video time on board the station.
It's a workhorse too. I mean, we've had thousands, 15 to 17,000 hours maybe of work so far.
Ma'am. And it's been very reliable to date. Here at Marshall, we've also done several other facilities as well. One of the more traditional research facilities is the Material Science Research Rack. That was also has some ESA hardware in it as well. The Microgravity Science Laboratory, but that facility does, like I said, the traditional research. We install samples, and they do directional solidification or quenching type of operations, and that's basically to study material properties, and hopefully someday that research will lead to better materials for use here on the ground.
It really is an international partnership. That is crucial to the whole space station.
Absolutely.
Also, let's talk about the Window Observational Research Facility. We have a role in that, and it actually plays into a bigger part, right?
Absolutely. That actually is a Express rack derivative, and Express is expediting the processing of research to the space station.
I'll make you say all those acronyms.
I may not even gotten it right, but those racks were some of the first payload racks that were first racks delivered to the station for conducting research, and they were centered around being able to use mid-deck lockers, which was some of the ways we did research on the shuttle. Mm-hmm. And so those racks were delivered, and I think there's actually 8 of them on board, and talking about thousands of hours of operation. I think one of the first ones has over 90,000 hours of operation now. But WRF, being a derivative of that, uses several of the same key subsystems, but it's unique in that it's mounted above the station window, so it's set up to do Earth observation science. And right now we have another Marshall payload that's installed in WRF called iServe, which is actually there for being able to photo and back of Earth and do some help with disaster relief. So I think some of the recent photos were of the flooding in the Cambodia, Thailand area earlier in the month.
Very important work. Let's talk about how emphasis has changed. I mean, you've gone from assembly complete to now it's really on the payloads. How is that for you?
Yes, ma'am. We've actually had a lot of changes over time. I mentioned the shuttle era. In that time frame, we had our missions were 10 to 14 days, very restricted, and so we had a lot of emphasis on doing a lot of very robust qualification and test program to make sure all the hardware worked right the very first time, and a lot of planning to get everything orchestrated for that short period of time. Well, we still do a lot of planning working with the station, but the hardware is different. We're more focused on reliability and maintainability as far as the systems go for conducting research. So since that hardware is going to be there for a long time, we want to make sure, nothing lasts forever, we want to make sure that we could replace things. So the whole design is geared around orbital replacement units to be able to keep things operating for a long time. But then the biggest shift is, now that assembly is complete, from the payload perspective, we want to make things as absolutely simple for payload developers as we can. So there's been an emphasis on COTS type of hardware, commercial off-the-shelf type of hardware, an emphasis on reducing the amount of verification requirements that it takes. And one of the unique things here at Marshall is we have, associated with the facility payloads I was talking about, we have ground units here at Marshall for both the material science research rack, the Glovebox, and
I've put my hands over there.
and the Express. We have a functional checkout unit. And so we have a real emphasis on helping the payloads develop their hardware and make it as simple as possible to get them on board. And we're able to do true end-to-end testing here, and we have the opportunity to work with the operations folks, and they can come over and help put their hands on the hardware as well. So it provides a unique capability here.
Well, thank you for all your contributions. Congratulations on the anniversary to you and Brian. And let's take a live look at the other folks who really made a contribution and continue to in the Payload Operations Integration Center. Jason Norwood is the pod today, the Payload Operations Director. And he says they've been working today with the CFE test run. He says Mike has been training Koichi on how to do his first solo run, which begins tomorrow. So I'm sure the payload developers in Portland and Cleveland are ecstatic about that. And that'll do it for us here at the Payload Operations Integration Center. Now back to you at Mission Control in Houston.